Okay, so we have a differential equation. We have y prime, we have plane x, we have plane y. So here are the steps that we're going to go through to solve this differential equation. Step number one is we need to rewrite this. Rewrite y prime as dy over dx, which I know you guys love. It's your favorite thing in the world. You love rewriting. I don't know why I can't say that word. Rewriting. You love rewriting y prime as dy dx. So dy dx is equal to 6x plus 1 over 2y. Next, step number 2, you need to get all the x's and dx on the same side, and all the y's and dy's on the same side. So in this case, I'm going to start by moving all the dx's over here, and I'm going to move the 2y over there. So to move dx, I'm going to multiply both sides by dx. So times by dx, times by dx. And if I multiply by dx on the left-hand side, these just cancel. And if I multiply by dx over here, I'm not going to distribute it. I'm just going to leave my numerator in parentheses here for a hot minute. And then I'm going to multiply the right and the left-hand side by 2y. So I'm going to multiply by 2y to cancel 2y on the right. And I'm going to multiply by 2y on the left as well. You guys see that? So that leaves me with, on the left-hand side, 2y dy equal to, on the right-hand side, I'm going to leave it in parentheses here for a hot minute, 6x plus 1, close parentheses, dx. Kinda, sorta. Okay. Step number 3. Let me move this over so you can see my super wonderful handwriting of all my steps. Step number 3, I'm going to integrate both sides. Integrate both sides. So I'm going to integrate 2y dy, and I'm going to integrate 6x plus 1 dx. So we just took a test on integrating. You guys should be like the best in the world at it. So if I integrate 2y dy, I'm going to kick this up a power, which would make it y squared, and then also divide it by 2. But then the 2's cancel. So this is y squared. Oh, and then there's a plus c because this is an indefinite integral. And then this is going to be equal to, this is going to become 6x squared over 2. So 3x squared plus, this is going to become 1x, and then plus c. All right. Step number 4, solve for y. So these c's both act as just plain constants, not consonants, constants. But they're not the same c though. So even though they're both c, when I subtract c from both sides, c minus c doesn't make 0 because they're technically different c's.
So one of them could be like 2, one of them could be 1.
Exactly. So c minus c actually still makes c, which is weirdness. If it helps you, you can call this C1 and this C2, and then when you subtract them, you could call it a different letter, like D, if that helps you. Or you could call them different letters from the start, but they don't cancel each other out. C minus C does not make nothing in this case, because those constants could have been different numbers. This could be a billion, this could be negative 58 billion, who knows? Yeah, sure. And so over here I've got y squared, 3x squared plus x, and then there's one more step to solve for y, right? Sorry, you said graph? Oh, okay, radical. And because it's an even root, it's going to be plus or minus because it's an even root. So plus or minus square root 3x squared plus x plus, I'm going to leave it c. You can change it to something else if you want to. And so that's what y is equal to.
Now you go plus c minus c?
Sure, it doesn't matter. You could call it minus c if you want to. You could call it plus c. You could change it to d if you wanted to as well. It doesn't matter, so long as it's a constant.
Okay.
So you can change this to D if you really wanted and have X, Y, and Z.
Z would be bad because that's used for something else later on.
It's the third
Use W.
part of the
W, X,
graph.
Y.
It's a 3D graph.
Yeah,
X, Y, and Z.
yeah. It's also used for things like the Julia set. So, yeah.
We're gonna learn
W, X,
that?
Y.
I don't know if we're going to learn it this year or not. I don't know. I mean, there's some topics in the fourth quarter that I haven't decided if we're going to cover or not. So let's take a look at your assignment.
Yeah, sure. Why not?
Everything makes more sense than the stuff we started off with.
Really?
Yeah.
The stuff we
I
started off
was
with
so
was review.
lost, like the first half of this course.
But that was review.
Well, it was awful.
It all makes sense when you talk. Like, I don't know what it is about you. Because, like, everything's right in the world, and I go to try to do it, and it's like, what?
No, it's like you understand everything and you look at your notes and it's just a whole bunch of numbers and you're like,
Yeah, and it all makes sense. Like, my notes are the same as his, but as soon as he starts talking, it's like, oh.
Okay, so question 1, 2, and 3, all you have to do is check to see, is this the derivative of that? And then you just answer yes or no for 1, 2, and 3. So is this the derivative of that? Yes or no? Is this the derivative of that? Yes or no? Is this the derivative of that? Yes or no? So I'm not going to bother going over those with you guys. So let's jump down to some of the meatier problems, like 4, 5, 6, 7, 8, or 9. Let's go through at least 1 or 2 of those with you guys, and then we'll get everybody on steadier footing, and then that way we'll be good. Yeah, there's no back, only 9 problems, and 3 of those 9 problems are yes or no questions. So like this one section was one section of your book that was at the end of the last chapter. Like this was supposed to be part of the last chapter you guys had. I split this off and I'm kind of making it its own chapter. You what? Yeah,
Will that be within this quarter or next quarter?
it's gonna be next quarter. Okay, so let's take a look at a few of these. Let's look at number 6, and let's look at number 5, because let's choose those 2 specifically. Yeah, let's choose those 2 specifically for some specific reason. 6 will become apparent in a second, but 5. Okay. So if I just secretly nasty. No, it's really not that bad. 6 is nasty. So let's look at 5.
Looks so simple, though.
I know.
But the X is in
Denominator. And I think it's the only one I did that on. Yeah. So here, first thing you're gonna do, step number 1, according to your notes, is to do what?
Rewrite it prime and DYDX.
Yeah, rewrite y prime and dy dx is equal to 3x minus 1 over 4y. Okay, the next step is to get all of the x's and dx's on one side, all the y's and dy's on the other side. So just like the one in your notes, because dx is in the denominator, you can just multiply both sides by dx and multiply both sides by 4y. That's what makes 6 more difficult.
I just flopped them.
Okay. We'll talk about whether or not that's mathematically sound in a second. And then also,
not,
note-
is it?
we'll talk about it. And then also multiply both sides by 4y. So 3x minus 1 in parentheses dx equals to 4y dy. And then, so step number 3, integrate. So we integrate both sides. And remember, these are indefinite intervals, so our answers have to have plus c at the end. So 4y integrated becomes 4y squared over 2. 2y squared plus c equal to 3x squared over 2 then divide everything by 2. So, see, even dividing it by 2, it's still C. Although it's C, so it's still just C. You can multiply it by 1,000, it'll still be C. You can change the letter again if you want to. You can make it E, but it's still technically C because you don't know what C is. Sure, sure. And now keep this for, and since it's an even root, make sure you do plus or minus. Because you don't know if it's distance and you have to positive or something like that. 3/4 x squared minus 1/2 x.
That's it?
Yep.
Okay.
Now it's 6, what do we have?
Okay. That one's not too bad, right?
Right.
Cool. Let's look at 6. So step number 1, rewrite the I don't know why I can't say it. Rewrite dy dx as rewrite y prime as dy dx equal to y over x squared. Okay.
So can I just do x to the negative half over y to the negative first?
You can, but here's what I'm going to have you do instead. Now you multiply both sides by 1 over y and by dx over y. This is more mathematics down. It's going to get you the correct answer. The other way won't get you correct.
Why?
I will show you in a second. Let me finish this way first.
I have a question, so why do you do it like that?
I will show you in a second.
Okay.
So let's finish it this way first. So dx cancels, and you're left with 1 over y dy equal to 1 over x squared dx.
Is this the same as dy over y? Or is it easier for
No, it's the same. I just like doing it this way because it makes it more clear in my head that it's y to the negative first.
Okay.
This is more
I
of
just
a-
didn't know if it was like easier to remember a step in there or something.
It's easier for me personally to remember it's y to the negative first if I write it that way.
Okay.
Your mileage may vary.
I was just asking.
No, it's fine. It's like that whole Volkswagen thing. You know? But, you know, the whole company's being taken to court because their mileage may vary.
Really?
Yeah. The whole big deal. Never mind.
I mean, I don't buy many Volkswagens, so I don't have to worry.
So, this is y to the negative first. If we integrate that, what does it become?
Negative 1 over y squared.
Hey, what is it?
I want negative ln.
No, you were super
Just
close.
ln.
Just ln. Let's see. So the reason it's ln is because if we pick this up from 1 up from negative 1 is y to the 0 power. That doesn't make any sense though. It's nothing. So the antiderivative of 1 over x or 1 over y is ln y or ln x. The antiderivative of x to the negative 1 power is ln x. It should be in your notes. Oh, I was late. And then this is, the antiderivative of this one is negative 1 over x plus c. Okay. Now here's why I wanted to go over this one, because I'm like, okay, I have 2 Panther bucks that I will give if you guys can remember how to solve for y if it's ln y equals negative 1 over x plus c. Because we went over this last year, like,
Log?
okay, that's general. I need you to be way more specific.
Oh! I know.
Okay, hold on. You need to write it on your paper. Don't be like saying it out loud. You need to write it on your paper. You think you got it written down, how to solve for y. Like you need to write y equals and then what y should be equal to.
Oh.
We spent like a quarter on this last year.
Why do you asking me?
I feel like that's right.
Okay. You need to write on your paper y equals, and then what you think y equals. Then raise your hand, I'll come around and check. It was even this time last year, if I look at last year's warm-ups, it's all like, solve this equation.
That's all I.
It's all logarithmic equations you need to solve by doing stuff. Wait, where? No. You're on the right path, but no. Okay, I'm sorry. You're not on the right path. You're super close. You're ridiculously close.
Boy. Can I try again?
You just need to change one thing.
Oh, here we go.
No, you're close right now. You're on the right path.
Huh.
That's not what you need to change. Okay. No asking me questions. Just tell me what y should be equal to. Cicely, you're the closest so far.
How am I that close from that one thing that I was trying to prove to you?
I know, I'm like looking at yours and
No.
How close is it?
You and Braden are both equally far apart. No. You're farther away now. Further away. You're further away.
What is this?
I'll show you. I'm gonna let you guys linger for just another second, and I'll just show you. Okay, I'll just show you.
Wait. Is it gonna be like this?
I don't even know what you wrote down here. No, not that.
Okay. You can just go now.
I'm gonna show you.
Spoil it, then.
What would be from last year? It would be from
I'm
this
in
year.
my notes from last year. I'm
Okay.
looking in the logarithm section.
All right. So this is log base e, and so to undo log base e, you need to do both sides e to whatever power. So if you do e to the log base e of y power, and then you do the same thing to this side, e to the -1 over x plus c, e to the log base e of y. That's like saying you're asking what is the color of a white house. Like you're essentially e to the log base e is undoing itself. So that's just y. And then this is e to the -1 over x plus c. Cicely, you had this.
oh my gosh.
Oh.
Oh, dude, I should have.
I should have read it wrong.
I did not read it wrong. You had your parentheses around the -1 over x. So that's how you solve it. We're going to be talking more about undoing logarithms next chapter. That's going to be a big factor coming up. I only threw this one on here randomly because I knew I would go over it with you guys as a class. There's none other like that on here.
Cool.
So don't freak out. I only threw it on here because I knew I would go over with you guys together.
Good thing you hit the top here 5 minutes or whatever. It's over
Yes.
I can turn it in.
Yes, you can turn it in and get exactly 55.5 repeating percent. You're right.
Okay.
Assuming you got 1, 2, and 3 correct. Assuming you got 1, 2, and 3 correct.
Well, I'm pretty sure.
Okay.
What did you say?
That's a pretty big assumption, though. It could be.
What did you say?
Who knows? So,
Just my luck.
there. You got the rest of it to do. All right.